major reason why we are doing the International Space Station Archaeological project is to illustrate and demonstrate the utility of social science research for improving spaceflight. We've been studying the space station since 2015, so a decade now. And in that time, we've carried out a number of different studies and even actually done archaeological fieldwork on the ISS. And what we've been able to show is that there are things you can do that are very simple that can also really make a positive difference.
Welcome to the Omar Alayli podcast, your go-to podcast for exploring the diverse fields driving space exploration and technology. I'm your host, Omar Alayli, and today I'm thrilled to be joined by Professor Justin Walsh, who is quite literally expanding the boundaries of archaeology into outer space. He's a professor of art history, archaeology, and space studies at Chapman University and co-director of the groundbreaking International Space Station Archeological project, which is revealing fascinating insights into how humans live and adapt far from Earth. Professor Walsh, Justin, it's great to have you here on our podcast. Thank you so much for making the time.
Thank you, Omar. I love this podcast, and I'm really excited to be a part of it.
Justin, most of us have this image of archaeology, perhaps Indiana Jones in dusty tombs or painstaking digs uncovering ancient civilizations. But your work radically expands that. Before we launch into space, could you ground our listeners in the fundamental essence of archaeology itself? Beyond the artifacts, what core human questions and universal principles also drive archaeologists?
Yeah, actually, I started out doing the kind of archaeology you're talking about. Well, maybe not exactly like Indiana Jones, but I started out doing classical archaeology, Greek, Roman stuff like that. I have excavated in Sicily and in Jordan and in Spain, as well as here in the US. But that's not the only thing that archaeologists do. It's certainly not the only thing that archaeologists can do. So I know that most people think about archaeology as being associated with the distant past. Of course, there's archeo right there in the name. But the fact is that archaeology is really a perspective on a certain kind of evidence as a primary type of evidence, which is what we call material culture. So material culture is, the objects that we surround ourselves with, the architecture that we inhabit, these kind of tangible objects, things, spaces, etc. And archaeologists are interested in understanding how humans have adapted to their environment and how they create societies and how they develop over time by looking at that evidence in particular, not exclusively that evidence, but primarily that evidence. So we look at the associations between people, places, and things in order to get a better sense of really what humans are, what they're like, what they do, what they think, all of those kinds of problems. And so given that we can look at any type of material culture, including contemporary material culture, it means we can study any place and any time. And so while it's true that the distant past is what most of us do, since the 1970s at least, there has been a branch of archaeology called contemporary archaeology that has looked at different aspects of the lives of contemporary societies. And we're just taking it a step further by looking at human activity in a different domain, but is where humans are carrying out activity. And so it's completely legitimate and useful, in fact, for us to examine that material and to try and understand who humans are and what they're doing.
Great. So if archaeology is fundamentally about understanding human adaptation, like you said, through the things we leave behind anywhere and anytime, you've taken that anywhere to its most extreme. For many, the term space archaeology might conjure images straight out of science fiction. Could you illuminate this fascinating field for us? And what exactly falls under its purview? Are we talking about Neil Armstrong's foot on the moon, this defunct satellites, the rovers on Mars?
Yes, all of that, in fact, and possibly more. And in fact, actually, space archaeology also looks here at Earth. So, the first thing you might think of, maybe most people will think of, who are your audience, might be that scene in 2001, A Space Odyssey, where they find the monolith in the Tycho was it Tycho Monolith Anomaly 1, TMA1,
Mm-hmm.
at the bottom of this hole, right, that they've dug, this trench, we can even say, right, this alien artifact. Well, archaeologists are not really necessarily interested in alien artifacts because we're interested in humans. But the idea that you could dig into the soil and learn something about human activity, well, maybe that's a possibility. So, yes, we are interested in material culture that is evidence for human activity in space or human activity that's directed at space. So, in that sense, you can imagine that we could just as easily look at, I don't know, your home office, but also things like, since you're a space architect, but also things like Cape Canaveral or Baikonur. We could look at like the various deep space radio telescope dishes, like Arecibo Observatory or Goldstone or any of the others that are all around the
Mm-hmm.
world. We could look at the development locations for space technology. So, we could go and look at, rocket test stands, or we could look at facilities that are being used even now for building rockets. And then, yes, we also are looking at what's off the Earth. So we're looking at low Earth orbit. The oldest object that's still in orbit right now is Vanguard 1 from 1958, all the way up to the most recent launches, probably just yesterday. And we could look at all of those objects to understand not only in a forensic sense what activities are happening, but
Mm-hmm.
also what are the meanings that are associated with those objects, the symbolic meanings. So, for example, we could look at Tranquility Base on the moon, and yes, we could try and reconstruct what were the things that Buzz Aldrin and Neil Armstrong did in their 22 hours on the moon at that location. Track the footprints and the objects, the scientific equipment, or what have you, or also the trash that they left behind.
Mm-hmm.
Fine, we can do that, but we can also actually look at this as an example of Cold War technology, right? So we could look at it within its historic context of a
Mm-hmm.
competition between the United States and the Soviet Union. We
Mm-hmm.
could look at it as also, as a masculine or primarily masculine endeavor. And I mentioned this because you could start to understand an overall space culture and call it even an Apollo culture, as a colleague,
Okay.
PJ Capillotti, has done. And then you could compare it to other space cultures, like
Mm-hmm.
the ISS culture, right, which is multinational and cooperative and multilingual and multigender and all these other things, right? And also builds on legacy technologies that go back to the 1960s.
Okay.
We could look at all of that. Now, even push it further out, right? Beyond low Earth orbit, we could go to geostationary orbit. We can go to the moon, as I just mentioned. We can look at Mars. We can look at the rovers on Mars, or like we could look at Ingenuity. And in fact, one side project that I'm currently working on is documenting the back shell and parachute of the Perseverance mission, because the
Mm-hmm.
Ingenuity drone helicopter took some wonderful photographs on Flight 26 back in 2022. And because of that documentation, we could say, okay, this is what the state of that equipment was 1 year after the landing.
Okay.
And we can then say, if anybody goes back, either directly or robotically, to examine those materials, they will have a baseline of comparison for what has happened to those objects. And we can treat them seriously as heritage, because obviously
Mm-hmm.
they are technological innovations and they are steps in the development of human activity on other planets for the first time. We can then go further out and we can look at, we have the Huygens probe on Titan, or we can talk about the Voyager and Pioneer probes all the way out, right now
Okay.
beyond kind of the fringes of the solar system. And all of that is potentially material that we could study as space archaeologists. It's a lot.
Yeah, it is. So this is a three-part question. Okay.
Absolutely.
It's it's a mind-bending shift to think of International Space Station not just as a cutting-edge laboratory, but as an archaeological site teeming with cultural data. Some listeners, particularly those focused on engineering or hard sciences, might wonder, with all the pressing scientific and technical challenges of space exploration, why is it crucial to also look through an archaeological lens? And what unique and vital insights does space archaeology offer that can't be gleaned from mission logs or engineering data alone? And how does this understanding particularly benefit the future human endeavors in space?
I think it's a fascinating way that you framed that question. That is to say, with all of the pressing space exploration that needs to happen, when people who work in space are often pushed to answer the question, why do we need to explore space when we've got so many problems here on Earth? So it's interesting that you're kind of flipping the script a little bit there, but I also mentioned that to say, maybe that should open people's minds a little bit to what I'm about to say. So the fact is that we have been active as humans in space since 1961, right? Since the first launch of a human into space. And since then, there has been almost no social studies uh, investigations, mostly not from lack of interest, but because of the lack of availability of information and the lack of integration of social scientists into the space domain. So this is actually a major reason why we are doing the International Space Station Archaeological project, is
Hmm.
to illustrate and demonstrate the utility of social science research for improving spaceflight. And I always say to folks who are working in space engineering that the problems that you think are purely technical are actually not merely technical. They also have social and cultural dimensions that you may not be aware of. And if you're not aware of them because they haven't been studied or explained in any kind of way, then you're not going to be able to come up with an optimal solution. You might be able to come up with a solution, but it might not be an optimal solution. For example, that makes what you're doing available or relevant to everybody.
Hmm. Yeah.
Um, we've been studying the space station since 2015, so a decade now. And in that time, we've carried out a number of different studies and even actually done archaeological fieldwork on the
Hmm.
ISS. And what we've been able to show is that there are things happening on the space station that the space agencies themselves are not aware of,
Okay.
and that they ought to be aware of because these circumstances or situations are ones that could have a negative impact on what they're trying to achieve. So, for example, in the experiment we did on the space station in 2022, we actually had the crew take photographs of 6 sample locations in different parts of the spacecraft for 60 days. Every
Okay.
day they took another photograph. And one of the areas that we looked at was what's called a maintenance work area. And this is a kind of a workstation that, according to the design principles that were in place at the time that this was created, which was NASA Standard 3000, had 7 kind of core functions. And the first function was to perform maintenance on equipment. And then number 2 was to be able to do certain kinds of science that didn't require specialized facilities like a centrifuge or a freezer or a glove box or what have you. And what we found in our 60 days of photographs of this space was that it was never used for maintenance in that entire period of time.
Hmm.
And it was only used for science 4 out of the 60 days. And the entire rest of the time, the objects on the wall and in the area surrounding were basically static. And many of
Okay.
them did not have a function that tied them directly to the core uh, goal of maintenance or science. There were writing implements and there were Huggy wipes and there were all kinds of things, the post-it notes and things like this, all kinds of things that didn't directly relate to maintenance. But because there was an enormous amount of Velcro in
Hmm.
this location, it was just a good place to put things that didn't have a better home. In other words, it became a storage location
Hmm.
in a spacecraft, which we now know notoriously does not have adequate storage. In that design standard that I mentioned before, storage was number 6 of all of the priorities, right? So our results suggest that either storage needs to become a higher priority for designers who are creating new maintenance work areas, or more and better storage needs to be created elsewhere so that this is not cluttered with things that don't belong there, right?
Hmm.
So that's a really interesting phenomenon. If you had looked at all the historic photos of the maintenance work area, you would only see people doing maintenance there or performing science there.
Okay.
But that's because nobody takes a photograph of a place that nobody is using or at a time when nobody is using it, right? We did. And so what we revealed as we have for several other locations across the space station, is that these places are being used in ways they were not designed or intended to be used. They get used for these kind of ad hoc purposes in accordance with contingencies that arise from various times. The crew, what's easiest for the crew, or you just get into a kind of a traditional way of using a space, and it takes on a new meaning, right? Well, so if you pay attention to that, the commercial LEO destinations folks, for example, they can really learn something about how to do things in the future, right?
Yep.
They say, okay, that historic usage, okay, we'll learn something from that. People working in space tend not to look backwards. They're always looking forwards, and I totally understand why. It's a part of the nature of the game. But also, if you're designing a space station, ISS has now been inhabited for almost 25 years. In fact, 3 weeks, after we're recording this podcast, will be 9,000 consecutive days of habitation of ISS.
Wow.
Which is extraordinary.
It is.
These pieces of equipment have very long lifespans. Mir was used from 1986 to 2001. So what you're designing now is something that's going to be used possibly decades from now. You want to get it right. You want to know as much as you can about how to design these things.
Okay. So, Justin, clearly you can't just pack a trowel and brush for a week and dig on the moon, at least not yet. Investigating human material culture in orbit or any other planet must present extraordinary methodological hurdles. So, how does a space archaeologist actually conduct the research when the site is hundreds of kilometers up or millions of kilometers away? Could you give us a glimpse into the innovative toolkit that you and your colleagues have had to develop?
Yeah, I think that it really comes down to taking a creative approach to reimagining what can be done with documentation that was created for entirely different reasons. That's really because, as you say, it is not possible for us to go and travel to any of these sites. And not only is it not possible for us to travel to do that, the ISS Archaeological project was actually directly inspired by the 2015 call for new astronaut candidates, which explicitly stated, as others did before and did later as well, that social scientists are actually prohibited from applying to become professional astronauts. That is not just a NASA policy. Until JAXA's most recent recruitment, that was always the case with every space agency. Nobody in the social sciences, nobody in the humanities, nobody in the arts has ever been allowed to apply to become a professional astronaut. Of course, we could leave the teacher in space idea aside for the moment. That's kind of a separate thing, and it only happened for one individual, right? I mean, one who was recruited and flew, and then there was the accident on Challenger, and then a later one who flew many years later, but they were recruited at the same time. As a result, it became evident that there's this sort of bias, an engineering bias, against the kinds of things that we want to do. Even though, as I say, I firmly believe, and I think that I've shown that we can really be helpful. And I think that we're starting to make some inroads with some of for example, the commercial LEO destinations companies in that respect. But to come back to the methodology that you were asking about, it's really, like, what is available. So on the light bulb moment for me in 2015 was realizing that there were thousands of photographs that have been taken of the inside of ISS. And that's really because ISS was first inhabited in November of 2000. And that moment coincided with the introduction of digital photography as a widespread consumer technology. And so as a result, ISS is much better documented through photography by orders of magnitude, because they weren't constrained anymore by how many canisters of film they brought with them. They could just keep taking photos and keep sending them down. And then on top of that, NASA in particular has published many, many images that were taken by the crew on Flickr. So we had, and then there are others that have not been published that we've had more limited access to after starting the project. But just knowing that there are like 10,000 images of the inside of the ISS, and that if we could take those images, and because they're digital, we could put them in chronological order, and we could say this. We can look at change over time. If we examine who's in which picture, where they're located in the space station, and what objects they're associated with, then we can start to map out the arc of behaviors and associations over the very long duration. And this is just also to explain to your listeners. You might say, why don't you just ask the crew about their experiences? We certainly can do that, and we have done that with some of them. But the fact is that we are all, I think we hopefully we can all recognize that we are all fallible witnesses to our own lives. And we aren't able to articulate every moment that's happened or all of the changes we've witnessed in the places that we live or the places where we work. And beyond that, there are probably things that you don't want to tell me about your last 6 months, right? You want to keep things private, or you don't want to jeopardize opportunities, like the crew might not want to jeopardize their next ride into space. So, and this is, none of that is to criticize the astronauts and the cosmonauts. This is simply to say that we can use this imagery particularly the interactions between the crew and the material culture of the space station in order to elucidate things that nobody could tell us about.
Okay.
And that's really where it started. And so photography has been a huge aspect of what we've done, but there are other kinds of evidence that we've used as well. So, for example, I was asked by one of the commercial LEO destination stations program executives, one of those companies executives, could you tell us about facilities usage on ISS? Because they're thinking, like, what scientific facilities are going to be most important for us to have on our space station that our clients are going to want? And I thought, and I was like, oh, maybe, I don't know. Let me think about that. And it took me a little while, but then I realized that there was a data source that I had come across earlier, which was the sadly now discontinued daily status reports that NASA published regularly until July of last year. And those were archived going back to 2009. And so NASA has published a spreadsheet with the name of every single scientific facility and given it a category, assigned it to a category. So that meant that all we had to do was scrape those reports from those publicly available servers and to count up how often each one of those facilities was used. Okay. 190 different facilities of all these different categories. And NASA had some basic categories like tech development or biological and biochemistry research, things like that. We created our own categories that were like freezers or centrifuges or astronomical or things like that. So we kind of were able to slice it a couple of different ways. We were then able to slice it up by 5-year increments so we could see trends over time.
Okay.
Like I could tell you that biological research used to be much more important, and now robotics is actually the most important in terms of how often it's mentioned. Facility on, specifically the Astreby facility, is the most used facility on ISS. And that's incredibly useful information that I don't think the space agencies would have been able to provide. I don't think they're tabulating which facilities get used the most frequently. And we were able to do it by using a data set that has nothing to do with that. This is just a kind of a transparency thing from NASA. Like, here's what we're doing with taxpayers' money. This is what happened on the space station today. And we took it for all the days since January 1st, 2009 up until July 2024. And we're able to turn something into that, or turn that into something.
Fascinating. So,
and it's I should say it's an archaeological question, like who's using what parts of the site, right? Okay. Or what parts of the site are being used. That really is an archaeological question. If I'm in Spain or Sicily, that's also what I'm trying to figure out. So even though it has this kind of commercial application in terms of making future space stations better, it's actually also what I do anyway. So
cool. A cornerstone of your work is the International Space Station Archaeological project, ISAP, which you co-led, which is a truly audacious endeavor to study an active, inhabited space habitat. I understand the project's genesis was quite compelling, sparked partly by an insightful student question and perhaps a touch of frustration with the traditional siloing of disciplines in the space programs. Could you share that origin story and then outline the core scientific and humanistic goals of ISAP? And what are you hoping to uncover by treating the International Space Station as a living archaeological site?
Sure. Okay. So there's actually two different stories that you're referring to there. Mm-hmm. The first is how I got interested in space in the first place as an archaeologist.
Okay.
And the other is how did ISAP get started?
Okay.
So how I got started in asking questions about material culture and humanity in space was indeed, as you say, it was a question from a graduate student. As I said, I worked for many years in Sicily
Mm-hmm.
at a site called Morgantina in
Mm-hmm.
graduate school, and that site has become kind of unfortunately notorious for having been looted in order to produce beautiful artworks that eventually ended up in major private and public collections, including right here in Southern California at the Getty Villa. And so I was from a kind of an early moment in my scholarship, I was very interested in heritage and how we protect heritage. So when I got my first tenure track job, which was at Louisiana State University in 2006, I created a graduate seminar for our master's students who wanted to work in the art world. And I saw it as kind of an ethics course for them to kind of introduce them to some of the problems they face. And the second iteration of that class, 2008, a student raised her hand and said, "What about stuff in space? Is that heritage?" And it's like, oh, what? What an amazing question. I had never thought about space at all. And as soon as I did, and I guess probably Tranquility Base was the first thing I thought of, I thought, oh yeah, that stuff's just sitting there. That's an archaeological site, right? We could definitely go back and study that. And I said, go write your term paper on that. She did. She did a terrific job. One of the things that she discovered, which had just started, was the Google Lunar X Prize competition, and that was a key moment, I think, in like kind of new space or space 2.0, because it was incentivizing small private groups to try and send a rover to the moon and send back video, and therefore to get them to develop the commercial potential of the moon. And they had various bonus prizes, and one of them was actually called the Heritage Bonus, and it was if they visited a previous landing site on the moon. And I was very concerned about this. I was
Okay.
very worried, and my student was as well. I mean, what we were saying basically was these are small groups with very little or no experience, and it's extremely challenging for NASA to carry out these missions with its budget and all of its expertise, et cetera. So we can imagine that they're likely to have setbacks, right? These teams doing and your listeners probably are aware that the Lunar X Prize competition was shut down with no winner. I believe it was in 2017. But several of those groups are still active,
iSpace
right? Like
including.
iSpace, for example,
Mm-hmm.
Beresheet, Space
Mm-hmm.
IL, that is,
Mm-hmm.
and have tried to carry out landings. And our concern was that since they were incentivizing groups to travel to previous sites,
Mm-hmm.
and many of these teams said, "Oh, we want to go to Apollo 11, or we want to go to Apollo 17," the last of the landing sites
Mm-hmm.
and the most extensive of the landing sites, that they would have what I would characterize as a catastrophic near success. That is to say, that they would crash into the site. They would get really, really close to succeeding, and because they were aiming at one of these sites, they would crash into it. Because the rovers were only being designed to travel 500 or 1,000 or 1,500 meters. They would
Mm-hmm.
have to imagine that they were going to land somewhere within that radius. And what damage could they do? So we wrote an op-ed that was published in the Los Angeles Times in 2009 saying, we really think you should withdraw this bonus prize. And the X Prize Foundation had no interest in doing that. But at least we started to raise the issue about how these sites were not protected, and in fact cannot be protected under the Outer Space Treaty. It's actually impossible for any nation to protect heritage at the moment in space.
Okay.
So that was really what got me started. I started digging deeper into that problem of the international nature of the space domain, and thinking about how we could build on existing protocols for protecting heritage in international context here on Earth. We can kind of take that work and kind of easily build a new protocol that would work for space. And I think that that was 15 plus years ago, but I think that slowly the snowball is building up and starting to roll down the hill and get a little bit more momentum, and maybe we'll see something like that in the next few years. That's how I got into space. But it always seemed that, and I did meet a couple of other people like Alice Gorman, who's my collaborator on ISAP, Beth O'Leary, who actually carried out the first space archaeology project from 1999 to 2002, which was about Tranquility Base, trying to figure out just what had been left behind there,
Okay.
because actually nobody knew, because some of the things that were left behind were not intended to be left behind.
Okay.
I met these people, and we were interested in heritage, but we were also thinking, like, there's no practical way to do space archaeology since we cannot go there. And then it was in 2015 that I had this kind of brainwave about how we could use photography to
reconstruct.
Well, to simply engage with the material culture, to observe the material culture of the ISS. And so that was my second light bulb moment. I think I might have left out the very end. What was the last part of the question that you asked me?
What are you hoping to uncover by treating the International Space Station as a living archaeological site?
And what are our goals, right? It was that, right? Yeah, so our goals broadly are to understand how humans adapt to this environment that we are not evolutionarily adapted for, right? It is unsurvivable for us. We cannot simply go to space and be there, right? We have to build these environments that we inhabit, and that protect us and provide us with as much of what Earth provides us as we can, although there are things that we still can't fully provide what Earth provides, right? So we can't provide total protection against cosmic radiation. We cannot provide, at the moment, gravity, although I know that's something that people are working on. We don't. So our bodies are not capable, truly, of existing in this space in a normal way. So this is one of the most interesting things. It's also actually funny. Alice and I have been talking about how concentrating on an environment where there is no gravity, or at least no apparent gravity, is directing our attention a little bit to how much we take gravity for granted here on Earth. But that's a separate issue. So we're interested in what are human adaptations to this. Second, as I mentioned before, what are the differences between how space equipment is designed to be used and how is it actually being used? And third, I would say we're trying to demonstrate that the social sciences are incredibly useful for folks who want to operate in this domain, who want to think about how to operate better in this domain.
Okay. Justin, you've mentioned that direct hands-on archaeological work on the International Space Station isn't feasible for researchers on the ground, of course. ISAP has become renowned for its ingenious proxy methods, like you said, the meticulously analyzing the millions of photographs taken by astronauts over 2 decades, or even creatively repurposing NASA's inventory databases as forensic tools. Could you walk us through an example of how you transform, say, a seemingly mundane photograph from the International Space Station or an inventory log into a rich source of archaeological data about human life in microgravity?
Sure. So the photographs, I mean, basically, it's just looking at the photograph. And, we have had to think a little bit about how we identify locational information within one of these photographs. Working a little bit, take a step back. Here on Earth, we just take out our GPS and we've got our lat long coordinates, right? So when we find something, we can say, okay, that's where that was located, right? As opposed and in relationship to whatever other things we're finding, which is really what we're interested in, not just the thing itself, but its relationship to other things in 3 dimensions. But in space, on a spacecraft that's traveling 28,000 kilometers an hour and going, between 52 degrees north and 52 degrees south, like obviously none of that matters. The GPS coordinates are not going to be useful. So we have thought about it, for example, like using the 3-axis, so we could talk about divide up the space of a space station module into obviously front, center, aft, starboard, center, port, and then overhead, center, and deck, as they do with the wayfinding signs that they have all over the space station. And if you use those 3 dimensions, you could divide up a module into 27 distinct locations, right?
Okay.
But in any case, let's just give you an example of how we have to think a little differently in the space context. But basically, like, where is that thing located in this photograph? Does it move? Does it change its location in the next photograph? What might have happened to cause that to occur? Did a new item appear? Did an item disappear, or did it shift its orientation? All of those indicating that it had been manipulated and therefore we could say used. And recording that data chronologically for every object that we see. So we did a pilot study of the Zvezda module, where there's this extraordinary visual display that's been created by the cosmonauts. And I just happened to see a photograph of it, and there's all kinds of objects. There's mission patches and flags, things you might expect on a space station that show kind of your affiliation, your identity, but other things as well, like religious objects, Orthodox painted icons, a gold Orthodox cross, photographs of Soviet space heroes, Yuri Gagarin, Konstantin Tsiolkovsky, and Sergei Korolev, and most recently Leonov, blanking on his first name, Alexei Leonov, after he passed away. Interestingly, we do not have Valentina Tereshkova up there, which led us to the question, like, is she excluded because she's a woman, or is she excluded because she's still alive? So we have to wait, obviously, to see if her image does get placed in that group after she passes away. But those images are up there as well. There are toys. There are paintings that are not Orthodox icons. There's just an incredible array of items on this wall. And I saw this picture and I thought, is that stuff always there? And so I started looking for other pictures of the same location. I realized, well, some of that stuff something is always there. But not everything is always there. It changes over time, and maybe that has something to do with the composition of the crew at that particular moment and their particular interests. On the other hand, there was this sustained interest by the cosmonauts in developing this location over time. They wanted, and it's also a place that they are aware is often visible on Earth because that's where they do video conferences. The Russians do their video conferences in front of that wall. So they're making statements not only to themselves, the way you might on your refrigerator door put up like your kid's homework or something like that, or your vacation photos, but also in relation to the Russian audience at home.
Okay.
So I created a database that was, this is where all those things are located on this wall. These are all the things, and this is over 45 or so pictures between 2000 and 2014. And by the way, that display is still up there. And there's one object that has been there basically since 2002 up until the present, continues to be there in every single picture. It is a portrait, a very famous portrait of Yuri Gagarin holding a dove. And he visited Bulgaria about a month after his flight, and he was given this dove by the Bulgarian young pioneers. And it's a very, very famous photo of him. And that is like the talisman. This is the thing that is always present. And it kind of shows that the cosmonauts see him as a hero and possibly even as a kind of a protective saint that watches over them symbolically, right? So, but the other things change from time to time because some of the cosmonauts are more religious, some of them are less religious, but just totally fascinating to see because the crew, of course, this is both their home and their workplace. And those distinctions are very blurry up there. So this is a way that they're making it homey. We even actually took a look back at Mir and the earlier Soviet space stations, the Salyut series space stations, and saw that the crews had been using that same location for the same purpose, going back as near as we could tell, back to Salyut 5, which is like 1976, I think. So, in other words, there was this tradition developed within the cosmonaut corps that this otherwise blank and unused space was something they could use for their own purposes, and that they wanted to use for their own purposes. And I would suggest, and I know this is not something that any space engineer is going to say, "Oh, this is a really important thing to spend a lot of time and money on." We're going to give the crew their own display space, but it clearly makes the crew happy. And anything that makes the crew happy is going to make them more efficient and healthier. And so I would suggest you should think about how you can, just with a little bit of thought and effort, create a space that the crew can use and call their own. How can they personalize this location? And if you don't want it to be visible back on Earth, like NASA would not want something like that visible on Earth. And in fact, we know that they tell the crew to sanitize places where they've created displays if they're planning to take photography or video that's going to be seen back on Earth. Create a shade that you can pull down over it, right?
Sure. Yeah.
So they can have it there, but nobody else has to see it. right? But then they can put the shade back up. It's our
Okay.
home again, right?
Yeah.
So there are things you can do that are very simple that can also really make a positive difference. You mentioned the inventories. This is something we haven't done as much work with, but it's just interesting. We were able to get the ISS, what's called the Inventory Management System, or IMS.
Okay.
We were able to get our hands on archived versions of that going from about 2011 back to the beginning of space station habitation in 2000. And what we found is actually it's really not clear how this database can be used or is being used, because there's zero data validation in it. And for your listeners who don't understand what I mean by that, if you have a database and you have the same item listed in that database and it's spelled differently or described differently, you are never going to be able to count it properly, which is really what you want the database for. You ultimately want to know, if you have a list of inventory items, you want to know how many you have and how many you're using and how many you need to send up, right?
True.
And you have the same kind of item. First of all, it's in both English and Russian. And then just within English alone, it will say 5-inch by 5-inch Ziploc bag, 5-inch by 5-inch resealable bag, 5-inch by 5-inch plastic bag.
Yeah.
And all of those are referring to the same item. So I'm not sure how that kind of gives me the sense of how the space agency is not looking backwards at all.
Okay.
Like they're just creating a list of what's there, and they're not really creating a list to understand how what was there was being used.
Okay.
And that's the archaeologist's perspective. So we made this thing searchable, and we made it so that you could search for multiple different variations on names as well.
Cool.
So we haven't used that as much as a tool, to be honest, but it really was a nice window for us into just the behind the scenes operations of ISAP.
Amazing. So perhaps one of the ISAP's most headline grabbing achievements was the square experiment, which you just talked about. I don't think you mentioned it by name, which is the first ever archaeological fieldwork conducted of Earth, where astronauts themselves became your archaeological field workers, meticulously taping off several 1 square meter areas on the International Space Station and photographing them daily. That's what you were talking about, right?
Yes, correct.
What was it like to direct an archaeological dig from Earth, observing via Vigilink as astronauts laid out your sample units?
Yeah, well, I actually kind of have to go a little bit further back to give a good description of it. Just the process of developing the procedures. So we were enabled to do this. It was a miracle, honestly, that we were able to do this, because as I mentioned, social scientists are not allowed to apply to become astronauts. But on top of that, NASA does not sponsor social science research. So if the Human Research Program, HRP, within NASA, only funds biological or physical science research or some psychological research, but no other research. When I've asked them, they said, well, maybe if you're a part of a larger project, you can do something. And there's not really a way for us to fit into a larger project. Similarly, with the ISS National Lab, which, for your listeners, is the entity that was chartered by Congress about 15 years ago to manage external research on the ISS, at least on the US side. And they actually have, by law, have half of the allocation of crew time, as well as the ability to launch supplies and to return scientific samples. So if you want to do research, you can apply to them, and if they decide to sponsor you, then you get access to those resources. They also do not sponsor social science research. They only sponsor biological and physical science research and tech development and commercialization of technology, those kinds of things. And it's also all applied research rather than basic research. So it was kind of a fool's errand to try and to say, well, let's apply to them and see if they'll give us a shot. But we had built a relationship up with some of the folks there since 2018. We met them at the International Astronautical Congress in Bremen that year, and they were interested in what we were saying and the fact that it could have a positive impact on future space stations. They really liked it, but they couldn't figure out a way to shoehorn us into their mission. And so they said, well, just send us an unsolicited proposal, and we did. And we outlined 6 or 7 ideas that we had for experiments that we might do. And they wrote back and they said, well, of these experiments, you can't do this one because that would require turning off power to a whole experimental rack, and so other people will lose their science. But these other things that you're proposing, you could do those. When you get money, come back to us, and we'll continue to talk.
Mm-hmm.
Okay, that's interesting. Cool. It's like they're not slamming the door on us. So we did start to apply to the National Science Foundation for money.
Mm-hmm.
But in the meantime, we got a message from these folks at the National Lab saying, this was in February, March of 2021, saying, we actually are going to have a couple of our sponsor payloads slip a bit. They're not going to be ready for the latter part of this year when we thought they were going to. So we're going to have an excess of crew time. Also, they just added a 7th crew member to the normal complement, so it went from 6 to 7 on ISS. And so we have extra crew time. Is there anything of those experiments you told us about that you could propose that doesn't require sending any new equipment to the space station, because it would take too long to certify new equipment? We'd miss that window of availability. We said, yes, we have this idea. It was Alice's idea to basically recreate an idea that archaeologists have been using on Earth for decades, if not a century or more, which is to sample a site by gridding it out in 1 meter squares and quickly excavating just a couple of them, which will give you a window onto what the rest of the site is like. And you can say, okay, now we're going to dig bigger trenches in these places.
The shovel test pit?
The shovel test pit. This is what this is called, exactly. And you've been reading our publications. I love it. So yeah, the shovel test pit. We're going to do this, and the idea was simply to put up 1 meter squares in different parts of the space station. And instead of marking them with string tied around nails at the corners of the squares, we would put up adhesive tape, but we could not put adhesive tape over the entire perimeter, just at the corners. So we just had these yellow capped on tape L's at the corners to mark the locations. And we chose 5 of them, and we asked the crew to choose a 6th. So based on what they thought was interesting, because of course we didn't have any direct experience. Why not ask people who are having direct experience what they think, even if they're are amateurs or don't know much about archaeology? We can explain what we're trying to do, and they can respond, and they did. But in developing the procedures, it was actually like parachuting into an entirely different culture. I had to learn I had weekly meetings with all the representative offices, the what's called the topology office, which kind of monitors where everything is and what the locations all look like inside the space station. We had to have a meeting with the astronaut office, a representative of them, to see, is it okay to take photographs of the inside? Are the crew going to be bothered in terms of the privacy? Are they not going to like that? But learning all the acronyms and learning, the way the steps were divided. Oh, wow. That was like an anthropological experience in and of itself. And then finally, we had the installation, which was on January 14th of 2022. Mm-hmm. Of course, this is like my giant leap. So this is why I remember exactly when it happened. And I was here in Los Angeles, and it was 6 o'clock in the morning, and I'm looking on Microsoft Teams, connected to Axiom. Actually, Axiom Space was our implementation partner. We were their very first payload on station, and we inaugurated their mission control, so that was kind of cool too. So the folks at Axiom were handling the logistics for us. We're in communication with Marshall Space Flight Center and Johnson Mission Controls, who were communicating, of course, with the astronaut who was Kayla Barron, who was installing the thing. I'm here in LA at 6 o'clock in the morning. It's 2 o'clock in the afternoon on the space station, and it's 1:30 in the morning the following day in Australia, where Alice is looking at it. And we're just watching this thing, and we're seeing Kayla putting up the pieces of tape and just thinking, oh my God, we're witnessing the first time a thing in our discipline is happening in space. This is so wild.
Yeah.
There were some frustrating moments for Kayla because, the way that the space station actually is different from the drawings. Mm-hmm. Hey, that's the learning experience right there. Yeah. But we were available to answer questions or give guidance based on our desires and needs for our science. Mm-hmm. So yeah, that, and then they started taking photos. And actually, at the beginning, the procedures clearly hadn't been written properly because we had some issues with the photos, so we had to come back for a week And then we restarted properly a week later. So January 22nd was the first day that we started taking those photos, and they continued every day till March 22nd. And so we have all those photos that we're still going through. We're still digesting that data.
Amazing. Thanks for sharing the story.
Yeah.
The data from ISAP and the Square are already painting a fascinating picture of the life on board this micro society in a mini world. We've heard about astronauts personalizing, like you said, their spaces with everything from religious icons to mission patches, creating kind of a space folk art, and instances where official workstations get informally repurposed, something like a busy garage workbench. Beyond these intriguing anecdotes, what are some of the broader, perhaps surprising patterns of human behavior and adaptation that are emerging? And crucially, are these findings offering practical, actionable insight for those of us designing future space habitats or planning long duration missions?
In answer to the second part of the question, I have to, of course, say yes, I think they really are. But I'll give you some examples.
Mm-hmm.
So, one of the things we did was we actually were able to identify the distribution of different groups of people across the space station using the photographs, or actually I should say in another creative reimagining of what this data can do or can illuminate. We didn't use the photographs themselves, we used the captions that were given by NASA on Flickr for each of 6,200 photographs between 2000 and 2020. And those photographs are, in each of those captions, the name of at least one crew member was given and a location was given. Jessica Mayer and Drew Morgan work on the waste and hygiene compartment in the Tranquility module. That would be an example of one of these captions, right? From that, we could say Jessica Mayer is an American female NASA astronaut. Drew Morgan is an American male NASA astronaut. We could do that for all the 250-ish people because we know that information about the very few people who've actually been to ISS, right? We know that basic information. And with that, we were able to say that, that we have this many men, this many women, this many Americans, Russians, Italians, Japanese, whatever, and this many NASA, Roscosmos, JAXA, ESA, etc. people.
Mm-hmm.
And so we could map out those distributions across the modules. And we discovered a couple of interesting things. One thing we discovered was that women were underrepresented in the photographs in every single module, especially in the Russian part of the space station, which is maybe not a surprise because up to 2020, they had only had one female cosmonaut on board. But in the US side as well, actually, women were underrepresented compared to their actual proportion of the population, which is only 16%, but these numbers were actually even lower than that. In every module except for the cupola, where they were 24% of the population. So in other words, they were overrepresented by 50%. This is kind of shocking. And what that indicates to us, at least, is that there is I'll give them the benefit of the doubt, unconscious bias on the part of NASA Public Affairs to feature photos of women in the cupola, women in this aesthetically appealing, beautiful setting with Earth, outside that panoramic window. So that's kind of interesting, and it reveals something about space agency practices. But perhaps more useful, talk about actionable information. We discovered that this supposedly international project has many highly nationalized spaces.
Okay.
So, for example, unsurprisingly, the Russians dominate in the Russian segment, and the U.S. dominates in the U.S. segment. Mm-hmm. But if you dig a little deeper, you can look at the Japanese lab, Kibo, and Japanese crew members were overrepresented 3 times as much as they actually are a part of the population. And in Columbus, the European lab, Italians were overrepresented 4 times as much as their actual proportion. What that suggests is that when people from those countries are aboard, they're specifically directed to work in their own agencies' locations. I totally understand why that's the case, but this is hard data that shows that it's the case. Mm-hmm. I understand from a geopolitical point of view, or we have to show the taxpayers that they're getting their money's worth kind of point of view. I understand that. However, big picture, ISS is the most expensive building project in the history of humanity. right? The 10-year-old estimate for it is $150 billion, right? So if that's the case, you should be trying to use your crew as efficiently as possible. Whoever is free should be sent to work on the next task.
Okay.
Because they are never, I mean, a key part of this is that no astronaut or cosmonaut is an expert in the science that they're doing on the space station. The only one I can think of is Kate Rubins doing the genes in space payload. She's a microbiologist, or maybe even a molecular biologist, and so that was one example. But in every other example, basically the crew is told what to do through procedures and is overseen by mission control. If that's the case, they're all Jacks and Jills of every trade. They can be assigned to work on anything anywhere, and that's not happening. So there is a lack of efficiency here, again, for reasons I completely understand in the context of the ISS program and our current situation. But if you are in commercial LEO destinations and you are thinking about how to manage your crew time in the most efficient way, you can learn a lesson from this. Yep. So that's a very broad scale example of how we can contribute. We did a study where I observed the cargo coming back from ISS on 2 occasions in 2018, because that's the only material culture from ISS that I can actually observe directly. I got permission to do so, and I had interviewed many of the contractors who work on returning and also sending up the equipment and the personal items and the scientific samples and things like that. And the real upshot of that for us was how much the crew's lives are governed by procedure and by lists of things. They are not given very much autonomy over how to work, when to work, where to work, or eat, or sleep, or have leisure time, or those kinds of things. They don't have a lot of control the way, like, even you could say, I don't like my bed up against that wall. I'm going to put my bed up against the other wall in that bedroom. That's going to work better for me. I don't like the light coming in the window, whatever. They don't have any of that flexibility, even though technically those berths in Columbus can be unbolted and put someplace else, because everything's supposed to be modular. In practice, it never is.
Okay.
So the lack of autonomy that the crew has, again, I understand why. In our current level of ability to function in space, that is the way things are. But if you are thinking about what a space habitat should look like in 2070, let's say, maybe you can think about, like, how am I going to really improve the ability of the crew to take control of decisions that impact their lives like they are able to here on Earth, because that's what's going to make them happy. And I think the 2070 thought experiment is really useful, because hopefully designers who are working now on the next generation of space habitats can say, if I think about 2070 and where I'd really like to see us go, what does that mean for how I'm doing things now? Right?
Yeah.
Can I start to think about how to open the door to getting to what I want in 2070? I think all the people who are kind of space geeks are aware that the inside of ISS does not look like Star Trek.
Yeah.
And maybe we're not going. Maybe Star Trek is not. Maybe that's not how spacecraft will ever look. But the point is that it's a more livable kind of life on the Enterprise than it is on ISS for a wide variety of reasons. But how do we bridge that gap, right? How do we get closer? It can't just be doing the same things over and over again because they're cheaper.
Yeah.
We should at this point be moving beyond survivability to habitability as a goal.
Yeah.
Like, at this point, we have now had the first permanent space habitat, 25 continuous years of habitation. What can we do better going forward?
Yeah, true. First of all, keep the collaboration internationally. Hopefully we will, when we lose the International Space Station, we don't distribute ourselves into small nation colonies in space. That's
Definitely.
Be the worst
I would also say, all you space engineers out there, consider bringing designers into the project before it's 70% done, because they can't have any positive effects and improve the usability the habitability of space equipment if you're bringing them in that late in the game. Like optimally, they're in from the beginning and helping you even design the goals. I really want to see that happen. I think that that's crucial. Designers, and of course, people like me who have developed data and analysis that gives you a hard surface to plan from. Like this is your foundation. Plan from this because this is what we know. It's not what we guess. It's what we know.
Yeah, true. Justin, a profound theme running through your work is the urgent need to recognize and preserve our cosmic heritage, from the Apollo landing sites, like you said, with their iconic footprints, to the artifacts now resting on Mars, like the prominent, like the components of the Perseverance rover, for which you're developing the formal heritage documentation, like you said in the beginning of the episode. As space becomes increasingly accessible with more nations and commercial entities venturing forth, why is it so critical to act now to protect these irreplaceable markers of human history? And what are the immense challenges, legal, ethical, and practical, in safeguarding heritage that exists in a legal no man's land and an incredibly hostile environment?
This is such a fantastic question. Thank you so much for asking it. Something that people who don't work with heritage are so often surprised by is that any interaction that you have
Mm-hmm.
with a heritage object or site, it can potentially have grave consequences that are irreversible for that site. So a key principle in conservation management of heritage
Mm-hmm.
is that anything you do should be reversible. So, for example, you're never going to find a conservator who is putting back together all the fragments of an ancient pot and they're using super glue. They're not going to do that because you can't reverse that easily, right? They're going to use epoxies that can be dissolved even with nail polish remover, acetone, right? That's how that work is done. Because if a mistake is made, you don't want it to be a fatal mistake, a terminal mistake for the object, right? So I know lots and lots of people are going to want to go back to Tranquility Base. We can imagine if, like, I tend to be a little more conservative in my estimates than maybe other people who are more enthusiastic. But like, I can certainly imagine that in 2069 for the centennial
Mm-hmm.
of the first moon landing, that people are going to want to go back and visit that site the way people did in 2011 go to the South Pole to recreate the first visit there, right? And I'm not sure that by 2069 we will have figured out this a safe way to interact with that site. We have, as I just said, 25 years of continuous experience living in low Earth orbit, plus other experiences. We have less than 2-person weeks of time on the moon by people. So there is so much we know about, or we don't know, excuse me, so much we don't know about how to operate well in the lunar environment, from how regolith acts when you are present. Like we know little bits, we know little things about it.
Mm-hmm.
We know it can be dangerous. We know it sticks to things. We know it's electrically charged, etc. We know that it can achieve bullet velocities when it's hit by rocket exhaust and travel perhaps over the horizon. So what is the implication of that for where you have to land in order not to impact a previous landing site? How far away is safe? Nobody knows. Nobody knows.
No.
The other thing, of course, though, is that heritage specialists have to acknowledge that not everything is equally significant. So there may be other sites that we can go to, and like where a Saturn 4B rocket body was trashed on the moon, was just dumped on the moon, or one of the ranger sites or one of their surveyor sites or something like that. That actually happened during Apollo 12, where Pete Conrad, I think, and Alan Bean, that they retrieved the TV camera and the scoop from Surveyor 3 when they landed within a few hundred meters of it. And maybe you want to say that that's the first real space archaeology. I would be okay with that. But going to one of those other sites would be a lot safer than going to a site that we really care about. And I
Okay.
would even argue that Apollo 11 is the most important archaeological site that exists anywhere, including here on this planet, because it will
Hmm.
always be the first place that humans ever set foot on something that isn't the Earth.
Okay.
So we really should be careful about that site. We should be very careful about Apollo 17. We should be careful in general with all of the Apollo sites.
Hmm.
Maybe then we have step down the rankings, right?
Hmm.
So I would caution people to think about the fact that how I feel like this is like Socrates saying, "At least I know I don't know." The fact is, we need to recognize what we don't know and what we can't control yet,
Okay.
relating to the activities that we would love to carry out on the moon, on Mars, etc. We have to be aware of our own ignorance and lack of ability. Because what I would really hate to see is the catastrophic near success that I was describing with the Lunar X Prize Heritage bonus, right? We saw, in fact, that Bereshit lost contact and then from like 1,000 meters, boom, right into the lunar surface. And we saw the same thing with Hakuto, right? And that was after 12 or 13 years of development. It was exactly what I was warning in my op-ed in 2009 would happen, and it
Yeah.
happened. Just fortunately, they were not aiming for a historic site. So, let's get a lot better at this. Let's really get some experience before we go back, right? And if we go back, I actually wrote a list of considerations for NASA in one of the lunar surface science workshops. I think it was the fourth one, where they're talking about permanently shattered regions of the moon, but also heritage. I'm not sure why I got pulled into that topic. And you have to justify why it is worth taking the risk that you are creating for objects that otherwise face no risk to their integrity.
Okay.
And I will say that here on Earth, this is something that archaeologists really take seriously. When we are digging and we see the tiniest bit of an object popping out of the ground, we don't just go with the pick or the trowel and okay, I got to get that thing out of the ground. I really want to see what it is. That'd be
Yeah.
cool. It's
With the
something.
brush. Yeah.
It's not just that. We dig around it and
Hmm.
around it and around it and around it and around it. And then as we get closer, we use a brush or a popsicle stick,
Hmm.
a tongue depressor, I guess they're also used, right? This kind of thing, just using the softest tools, because that object has survived for thousands of years until that moment. Who's creating the risk for it? Me. So the only one that has responsibility for mitigating that risk is me.
Hmm.
And I have to have a good reason for creating that risk in the first place. So it's the same principles that I'm talking about on the moon, that we
Hmm.
want to see that, first of all, the moon as a whole is seen as part of the heritage of many people on Earth. And you can even say that the moon is the one thing that all members of our species, since the time our species developed hundreds of thousands of years ago, we have all shared a connection with that thing.
Hmm.
There is hardly anything that exists or that ever existed that every member of our species has engaged with, right? So the moon is special. It actually
Hmm.
needs to be treated as special. Um, and the objects on it should be treated as special.
Yeah. This is such an important subject. I want to go back to what you talked about, the Outer Space Treaty of 1967, because it wasn't drafted with the heritage
No,
preservation in mind. You're a founding
I,
member.
I can't blame them for that, by the way. The
Yeah.
first International Heritage Treaty didn't come out until 1970.
Yeah.
So, the Outer Space Treaty actually predates that treaty.
Okay. So you're a founding member of the Scientific Committee on Airspace Heritage. What kind of new international dialogue, legal frameworks, or even best practice guidelines are needed to ensure that future explorers or commercial ventures don't inadvertently damage or destroy these precious sites like you are advocating to?
Right. So this develops right out of that last question, right?
Yeah.
So we have this group, the International Council on Monuments and Sites. ICOMOS is kind of
Nicholas.
the world leader as an NGO that is concerned with what we call non-movable or non-portable heritage. So really sites and buildings. And we started this scientific committee. There are scientific committees for all kinds of heritage under ICOMOS, but we started this one on aerospace heritage in 2022. And it includes architects and archaeologists and historians and historic preservation officials. And what we're really interested in is creating awareness about these problems, because obviously most people don't understand how much that there is, for example, 180 or 200 tons of human material already on the moon. This is kind of amazing. Since 1959, I believe, with the original Soviet Union mission Luna 2. So since that time, we put all that material up there and carried out all kinds of innovative activities. So the moon is one area that we're interested in. Also sites here on Earth, as I mentioned before, a site like Arecibo Radio Telescope, where that the instrumentation platform fell into the dish in 2020. We've been involved with developing plans for the National Science Foundation to manage that as a historic site going forward. In fact, which is their obligation. But we've helped them to develop the precise plans. Our biggest success so far was that at the beginning of this year, we were able to persuade the World Monuments Fund to place the moon on its World Monuments Watch. And the World Monuments Watch is designed to draw attention to heritage that is in peril for one reason or another. And of course, we understand that the heritage that is on the moon is not in peril maybe right this second. But we also are aware that there are many, many plans to travel to the moon, to study the moon, to exploit commercial resources on the moon, and that this is happening all without any thought for the heritage consequences, or indeed the symbolic consequences. I mentioned before, how significant the moon is in many cultures. The Outer Space Treaty states very clearly that if space is to be developed, it is to be developed for the benefit of all of humanity, not just the ones with the money and the power. And that is a clause within the OST that has really been ignored from the moment that it was signed, right? And we've seen pushback from various countries, like we saw the Bogota Declaration in the 1970s, where the countries that are around the equator attempted to lay claim to that incredibly valuable part of orbital space that is directly above them, and because they know how valuable it is. And they're really saying, they're not saying like it's ours, it's definitely ours and we can control it. They're making a rhetorical argument saying you should be taking us seriously. We need to be included in these discussions. And we're going to do it in this kind of flamboyant way by saying it's ours, even though they can't really defend that claim legally or militarily. I really do want to see the space industry come to terms with its responsibilities to all of humanity. We can't just be kicking the can down the road like we'll mine our way out of this problem. Oh, we'll go get helium-3 on the moon and that'll solve that problem. Well, do you know how long it's taken that helium-3, that actually tiny amount of helium-3 that's on the moon to accrete there? Oh, it's been 4 billion years that's taken. Where are you going to go once you use that up? It's like let's think about how we do things on Earth better before we put all our beans in that basket. But also before we do the irreversible damage that I was describing before, because resource extraction, of course, will do that kind of damage. So I'm not saying that I think mining should never happen on the moon. I certainly just want people to be more open and transparent and honest about what they're planning to do and what the consequences are going to be, and how they're going to mitigate that and deal with the concerns of other people on Earth about what's going to be happening. So that's a long way maybe from ICOMOS and heritage, but I do think it's all kind of wrapped up in the same conversation. We are focused at the moment on trying to interface with UN COPUOS right? The Committee for the Peaceful Use on the Peaceful Uses of Outer Space,
Mm-hmm.
which seems to be the best vehicle for promoting a new treaty that would protect heritage on the moon and potentially elsewhere in space, because that's important. I mean, another thing that I try to do is, my discussions with people in the space industry is to ask them what their post-mission plans are. Like if it's just deorbit, that is not necessarily going to be good enough anymore, because we know from a 2023 report from the National Office or National Administration on Oceans and Atmospheres, NOAA, I got it backwards, National Oceanic and Atmospheric Administration. They have now reported that there are, what's the word I'm looking for? That there are identifiable levels of heavy metals in the atmosphere from the decades of deorbits of satellites. And so these detectable levels really are a kind of, maybe that's the canary in the coal mine. We all know that we have a huge space debris issue, right? And how are we going to deal with that? Well, maybe there's the IADC protocol that says anything that's up has to come down within 25 years or be boosted to a higher orbit. And everybody's just saying, oh, well, we'll deorbit because that's easy. That'll pose the least amount of risk. Well, now you're dumping heavy metals into the atmosphere, and also some percentage, perhaps up to 40% of that material, as we know from the Columbia breakup in 2003, 40% of that material may survive to hit the ground.
Yeah.
So, or the water. It's typically the ocean that's the target. But like, how long can we keep dumping things in the ocean? That's where ISS is going to go. It's a 450-ton space station. I know the Pacific Ocean is big, but how much longer can we do this?
Yeah.
We all know about the Great Pacific Garbage Patch and microplastics in the ocean, and that there was like a beer can found at the bottom of the Marianas Trench, right? How did that happen, right? We can't keep throwing stuff in there. So we're going to have to come up with better methods of, for example, reusing the material that's in low Earth orbit, right? Setting up spacecraft that can recycle and reuse that material. Because it's already up there. Then you don't have to launch it either. That's also a good thing.
Yeah.
But anyway, I'm rambling a bit. But the point is, we need to think about these practices long and hard as space activity continues to ramp up. We can't just keep doing things the old way.
Yeah, I agree. Justin, your team is already employing machine learning and computer vision to sift through the immense photographic archives from the International Space Station. Looking forward, do you envision the next wave of technologies, perhaps virtual reality for immersive site reconstructions, augmented reality for overlaying data on the future lunar or Martian explorations, or even advanced robotics acting as your remote archaeological assistants? How do you envision these technologies further revolutionizing the field of space archaeology?
Actually, our first idea for how we were going to study ISS was that we were going to take all of those photographs that had been published and unpublished ones, if we were able to get them, those thousands of photographs, and we were going to create a kind of a 4D VR model so that we had, ISS there digitally, and then we would position the photographs over the parts of the space station that they depicted and have them layered like Photoshop layers, but also like stratigraphic layers in archaeology, have them layered by their chronology and with a kind of a timeline that you could move so that the pictures would come on when you hit the time that they had been taken and then disappear. And that was our original idea. And it was going to be really cool, but it also was not going to be a really good research tool. It was not going to be good for quantifying information about the ISS. It would have been an amazing didactic tool. That is to say, to teach people about what the space station is really like and how it's changed over time. Who knows? Maybe at some point we'll do that kind of thing. We also have just in our research been thinking about the sensory environment of ISS, the noise, which is very loud from the ventilation system. The smell of ISS. We've thought long and hard about this. The smell of the ISS is notoriously bad because, of course, it's been a closed environment for 25 years, and the people who live there can't wash easily. They're wearing their clothes for weeks at a time, and they're exercising for 2 to 3 hours a day. So you can imagine, and I have smelled the smell. I know what
Yeah.
it's like, because when they opened up the cargo bags and they brought them back, you could smell it. It's potent, and it's truly evocative of what kind of a place ISS is. And I would actually really like to sample the air of ISS and create an exhibit that recreates that smell, not just for current audiences, but for the future, because we're going to keep designing space habitats, and hopefully they're going to be better and smell better, or at least smell less than ISS. And I think people will want to know that this is what it meant to live in space permanently for the first time. And not only that, but smell is it's the one sense that we have that is directly connected to our memories and the creation of memories, because that nerve is connected directly to the amygdala and the hippocampus, where
Mm-hmm.
memories are created. And it's why when you smell something from your childhood that you liked, you are instantly taken back to that moment. You're transported in your brain instantly
Mm-hmm.
to that. Right? We have such a profound connection to smells, and so I really like that idea of as a form of heritage preservation, long term, and in other words, creating a memory
Mm-hmm.
of this place, because it's going to be destroyed. Right? I do think about the fact that we are documenting this site before it's destroyed. There's the clock is ticking, and we only have so much time. And after that, we will not be able to study it directly.
Mm-hmm.
So, what are the ways that we can do that? And smell, I think, is a really appealing way to do that. Um, yeah, I think, I mean, and also thinking about how we can make future space stations smell better. Can we create dispensers of volatile organic compounds, which are the substances that we sense as smell, uh, like cut grass or
Mm-hmm.
petrichor, the smell that happens after a rainstorm, which is
Mm-hmm.
what the crew says they miss the most. They they can't get wet. They can't get in the shower. Whatever. Scott Kelly, when he came home, the very first thing he did when he got to his house in Houston, he walked straight through the house and jumped into the pool in his backyard, because he just wanted to feel water on his body after a year. And maybe also because it was relieving the gravity that he was
Yeah.
suddenly
Okay. Yeah.
subject
Yeah.
to.
True.
But he said it was because he wanted to feel the water on his body. So how can we create those experiences, or experiences like those experiences that that the crew can experience? That would be great.
Justin, you've already pioneered efforts to document human heritage on Mars, which is an incredible frontier. What does Martian archaeology or lunar archaeology look like in practice today, especially when dealing with robotic explorers rather than established human habitats?
It's extremely challenging. What we're limited by is, what makes the ISS project possible is that there's so many photographs and there's so much other documentation, and that's just not the case on the moon. Like, we have the Lunar Reconnaissance Orbiter, but its resolution is maybe 1 meter, right? And if we
Mm-hmm.
want to be able to see what's really going on at Tranquility Base, we would need something like 10 centimeter or less
Okay.
resolution, right? So we just don't have good imagery that gives us a great sense of what's going on. And that was why I was inspired to do the Martian Heritage Project.
Mm-hmm.
As soon as I saw, essentially, for folks who are not aware, um, Perseverance landed on Mars in 2021, a year late because of COVID, but landed on Mars in 2021, and it included in its kind of ensemble the drone helicopter Ingenuity,
Mm-hmm.
which was an incredible piece of technology. First time power flight had ever happened on another planet. And uh, a year or so after the landing, maybe a little more than a year after the landing, Perseverance happened to roll past the landing site of its own back shell and parachute, which are part of the entry, descent, and landing components for that landing sequence. And those, at a certain point, the cone that was the back shell, which also had the parachute attached to it, popped off of the top of the rover. and just fell over where it was. And then the
Mm-hmm.
rover continued and landed in a different location. And so from about 500 meters away, Perseverance saw the red and white flapping parachute in the wind and a little bit of the top of the cone of the back shell on the surface. And it continued rolling. And when I saw that image, I immediately started cold emailing everybody I could on the Perseverance team saying, you've got to send Ingenuity there. You've got to send Ingenuity there. Please document this heritage. You've got this thing that can fly there, go there. And finally, I got an email back from Rob Manning, who was the chief engineer at JPL, and he was very kind and also very positive.
Mm-hmm.
He said, we're already actually planning to do that because we want to do an engineering autopsy to see how the equipment performed. So what failed, what worked well, etc. And so sure enough, they sent it on a flight and they kind of did a little bit of a U around
Mm-hmm.
the equipment strewn there on the landscape. It came up with a series of photos, but one of them is really iconic where you see the cone smashed. It actually hit directly onto a ridge of rock and it kind of smashed at about, I think they said it was like 80 kilometers an hour.
Wow.
Hit that rock. And then the parachute is kind of like strung out in one direction along that ridge. And that parachute, by the way, is a cultural object because it had an Easter egg as part of it. The red and white, the red and white panels spell out a hexadecimal code that read "Dare Mighty Things," which is the JPL motto, and the lat long coordinates of the Jet Propulsion Lab. And so that it's got writing on it, and that was a message that was intended for people on Earth, but it was still a message. I mean, maybe also intended for people on Mars, but eventually when they get
there.
But in any case, what I and a recent PhD graduate in historic preservation at UCLA are trying to do is we are using the photographs to try and map the location of the parts as precisely as we can. And what we're trying to do is fill out a form that is a standard National Park Service in the United States form called a Historic American Engineering Record. And so you can do this for any historic piece of innovative equipment, but we're doing it for equipment that's on Mars. And the idea is, you fill out the document, you say all the information about why it's important and where it is and what have you, and you provide the documentation that you got, and then you submit it to the Park Service. And if the Park Service accepts it, they then deposit it as a permanent record in the U.S. Library of Congress, which is the library of record for the United States. And if that happens, and I've already, I've been in conversation with the guy at the National Park Service who runs this program. He's very amenable to it because he's actually ex-U.S. Navy, and so he has documented heritage that is located outside of U.S. boundaries, and so he's not worried. So what difference does it make if it's on another planet? It's outside the U.S. boundaries, so we've done it for other objects here on Earth that are outside U.S. boundaries. So it would be the first heritage documented to federal standards in history on another planet. That's really the idea. I mean, it's not that the back shell and the parachute are the most significant parts of the ensemble. Obviously, the rover and Ingenuity are. Ingenuity even has a piece of the Wright Flyer inside of it. I don't know if you knew that. There's a 1 centimeter square of the wing of the Wright Flyer, which is in the National Air and Space Museum. The curators there cut that piece of the fabric and gave it to the JPL, and they put it inside Ingenuity, and it's on Mars.
Wow.
So obviously those are more important, but I don't have the documentation of those objects as heritage objects that I have from these photographs that Ingenuity made.
Okay.
So that's why I'm focusing on those, because I have evidence I can work with. And I'm trying to show that heritage exists on another planet. Heritage, by our traditional definition, exists on another planet. And actually, I have an ulterior motive that goes even further, which is that if you can start to think of these places as being heritage, maybe you can also start to think of them as simply being environments, like environments on Earth. And if you think of them as environments like we have on Earth, that behooves you to think about them the way we think about environments here on Earth. That is to say that you need to respect those environments. You can't just do whatever you want because you think that nothing lives there. There are climatic processes that need to be respected. There are physical processes that need to be respected that you're going to disrupt potentially, as we know we can disrupt them. And many people are like, I want to disrupt them. Let's terraform Mars. And it's like, well, you want to do that like by nuclear bombing it and by injecting dust into the atmosphere? These are like, if you were doing that on Earth, those would be the worst sins you could possibly carry out, right? And then you're like, then again, that'll raise the temperature, and then I'm gonna add like lichen and moss to start to raise the oxygen level. And it's like, have you seen what happens when we introduce species into environments that are not equipped to handle them? You've heard of the term invasive species. It's an ecological disaster. Exactly. So like nobody is really thinking these things through. Can we think about these places as places that are deserving of our respect?
Okay. So let me ask you a question here.
Why are they exempt from our thinking about them as exempt just because they're someplace else?
Okay. So you said the designers should be integrated into the mission early on. Should also space archaeologists, because the lack of rules and regulations requires experts to say, hey, until the regulations are there, you should be taking advice from experts who can translate the mission into a success.
Yeah, nobody wants to hear the R word, regulations, right? I know that. But the fact is that we don't need to be involved in every mission. But I do think that it's important for people like us to have a seat at the table, in kind of setting, what are the ground rules that we all accept are actually important for us to follow in this new domain, right? And I think actually, for as much as industry might say, like, we don't want you constraining us through regulation because we want to be creative, and also it's a very difficult environment to operate in. Guess what? We want you to be good at this. We want you to be able to succeed. But the way you do it is not by just burning everything down, right? The way you do it is to be thoughtful and also taking into account all of the possible issues that you might have to. I'm sorry if that complexifies the situation for the space industry, but we have seen what happens when industry is allowed to just go and do whatever they want, right? We've seen the mayhem that is created and that then has to be cleaned up or can't be cleaned up, again, because they're irreversible damages. And so I think it would be really nice to see the agencies and industry open up to a broader discussion with communities that they haven't traditionally, engaged with, and to do so not just like, I'll listen to what you're saying, and then I'm going to go and do the things that I wanted to do anyway, but to legitimately be open to like, what can I learn from this? How can it make what I want to do better? How can I use this to help me succeed? And not just like, oh, here's another roadblock. Oh, here's another rule. Here's another obligation. Won't these people ever stop? It's how we need to think on our own planet as well about the relationships between industry and everybody else.
Okay, to sum things up a little bit, what is the single most important takeaway about how this discipline, space archaeology, will continue to provide critical, practical insights that fundamentally shape the success, sustainability, and the essence of human space exploration?
Look, I think at the moment we're still dealing with a lot of low-hanging fruit because nobody has ever asked these questions before. And so on the one hand, as I say, we are definitely coming up with what I think are interesting, actionable, useful insights that can really help people do what they want to do in space better. What I'm really excited about is the future. I'm excited for the idea that there are going to be new space archaeologists coming along, young scholars, and anthropologists and sociologists and historians and whoever. I started, as I said at the beginning of this, as a Greek archaeologist. Alice started doing the archaeology of Aboriginal peoples in Australia and stone tools. Beth O'Leary, whom I mentioned before, was the first space archaeologist. Her work was in the Yukon on First Nations peoples. And none of us came to this initially, like from the beginning, like I know about space and I'm coming to this and I'm going to bring the two disciplines together with that knowledge from the beginning. We've had to educate ourselves kind of going along through the process. I'm really excited to see what the next generation does.
Yeah.
With as kind of space-born, space social scientists. Yeah.
Okay.
Exactly.
Okay. Cool.
They're going to be thinking of questions that I'll never have thought of. They're going to be thinking of methodologies that I'll never have thought of. That's what I'm really excited about.
Okay. So, but still, for you, what are the next big questions you're hoping to tackle?
I would say the thing I would love to do next is trash. I am super excited about the idea of studying trash from the International Space Station, if I can get my hands on it. Because believe it or not, nobody has ever studied ISS trash. Nobody has studied trash from a space station of any kind before. So we have some studies of wet trash from a couple of shuttle missions about 15 years ago, and that's it. But I do think sustainability is going to be a huge issue going forward. And it's hard to think about how you can make a mission more sustainable. That, for example, how you can reuse, recycle, reduce waste. How could upcycle, create something that's new and usable? If you don't know what the state and the characteristics of the trash are, and nobody knows that at the moment. They know many of the items that are being discarded, but they don't know what state they're in. And what we want to do, I have a team that I put together that can look at this from the entity level to the molecular level and think about like how this stuff can be reused in new ways, which is important, not just for reducing the number of cargo flights to an orbital space habitat, but for a Mars mission that's unresupplyable. You want to be able to think about what you can do with what you're bringing aboard so that you can make sure that you can keep getting use out of it after that first use. So that's a big one for me.
Yeah. I have to ask this before we finish. How do you feel about the International Space Station being decommissioned and the ways they're thinking of decommissioning it?
I understand the rationale that it's this giant object that will become a danger, and its altitude will steadily decline, and eventually it will have a decontrolled deorbit if we don't have a controlled deorbit. I mean, I think it's really interesting that there's only been one space station that was ever deorbited on purpose, which was Mir, and that landed 3,000 kilometers short of where it was supposed to. So we don't have a lot of practice at this, and we don't have a full success. And ISS is 4 times larger than Mir was. So, I understand why it's happening. I wish it weren't happening. I wish there was a commitment for these historic objects, also, for example, like the Hubble Space Telescope, to boost them to a kind of a museum orbit. And I understand the fuel that would cost and the cost of developing such a mission. But if I had my druthers, I would definitely like to see that. I think it's a real shame to get rid of something that was so important and innovative. At the same time, as I say, I'm going to continue doing my best to document it. I know I do understand that some of the commercial LEO destinations folks have kind of batted around the idea of maybe we can take one of the modules off and attach it as a museum to because they want to do space tourism, attach it to our habitat. I don't know how feasible that is. I don't know what the costs of that are. At a minimum, I would like to see that happen. I am in conversations with curators at the National Air and Space Museum because they have the right of first refusal, really, for objects that are coming from NASA, and they can also request objects. They're limited by what can be brought back. We don't have shuttle, so you can't bring back a module. A little aside here. When the first environmental impact statement for ISS was done in the early 1990s, they actually said that at the end of life, they were going to take it apart module by module on shuttles and bring it all back to Earth. I think that was before they thought about the fact that it was $1 billion a flight. But in any case, in the second environmental impact statement, they just said we're going to deorbit it. They quickly realized that probably was not economically viable. But all they have that they can bring things back on at the moment is Cargo Dragon. If Dream Chaser comes online, that I've been told will be a game changer for cargo capacity.
Mm-hmm.
And so maybe we can get some larger objects, but like what will fit through the door, the hatch of Dragon at the moment, right? Like that's kind of what you're limited to.
80
if
by
you
80,
want to bring
I
things
think.
back. Yeah, and exactly. And then you're also competing with the scientific cargo that needs to come back. So that's a justification that you have to make to be able to bring that back. But we are in conversations about like what based on my experience would be very a good storyteller, very evocative about what life on the space station was like, but that also would be viable to bring back. We'll see. And I could say if Dream Chaser is a viable option as well, maybe we can do some more.
Yeah, hopefully.
But I ultimately, ISS was supposed to be abandoned in 2016. So we're already 9 years past that. That's pretty good. Yeah. I would really like the people who are designing the next space habitats to think about this now.
Yeah, true.
Come up with a plan now, because probably it's going to be innovative and historic, and people are going to want to look at it.
Yeah.
So how are you going to meet that challenge? I know, again, it adds cost, but think about the fact that what you're doing is a big deal.
It's also interesting challenges for entrepreneurs to figure out new technologies. But yeah, this is where there's a challenge, there's always a way for entrepreneurs to figure things out. Before we wrap up, is there anything else you'd like to share with our audience or advice you'd like to share?
I think I've said enough already. I've been talking an awful lot, but I will say that people should check out our website at issarchaeology.org. They can also find me on Bluesky at JSTPWALSH.bsky.social. I'm keep looking out for news for what we're doing, because we keep developing this project further. So
yeah, I'll put those information in the description.
I will also mention that together with another colleague, Fred Sharman, I have a habitat consultancy called Brick Moon. And so if you are building a space habitat and you want to know what I know, please reach out. We're at brickmoonspace.com. And we provide educational opportunities for companies that are developing space habitats. We write white papers on space habitats and also give formal responses to designs. So I think that what we know, we've published a number of articles, and there's a lot of information in those scholarly articles, but there's a lot more that we know that kind of is in the spaces between those articles that can help companies achieve what they want to achieve better.
Justin, it's been a privilege to have you here. Thank you so much for sharing and your insights and expertise.
Likewise, Omar. Thank you so much.
To everyone listening, this is Omar Alayli podcast. Thanks for joining us, and keep exploring.